Good morning students, welcome back in e-learning videos of physics. In earlier lecture, we have to complete one topic named as wave optics. But today we are going to start one new chapter named as current electricity. We have also seen this topic in 11th standard, but the new points are added in these topics, and again this topic is added in new syllabus and named as current electricity. We know that the current electricity topic is very simple and we have to learn it very easily because the terms in the chapter are very interesting. In this case, first we have to see in this topic introduction of the topic. We know that initially what is meant by current or what is meant by electric current or what is meant by current electricity. All terms are related to the electric current because first we have to see what is meant by electric current. The first simple concept or simple definition is what is meant by electric current. We know that the rate of flow of charge through a conductor is called as electric current. The simple definition of electric current is that the electric current is the rate of flow of charges flowing across the area of conductor is called as electric current. The rate of flow of charges through the area of conductor is called as electric current. We know that there are two types of charges, positive charges and negative charges. We have to see later what is meant by positive charges, what is meant by negative charges in electrostatics. But today we have to only see what is meant by electric current. Electric current is defined as the rate of flow of charges through the area of conductor is called as electric current. We know that the electric current is measured in ampere. The SI unit of current is ampere. They define 1 ampere, right? म्हणजे आपल्याला इथे काय डिफाइन करायचं आहे? फर्स्ट आपण डिफाइन केलं इलेक्ट्रिक करंट म्हणजे काय. तर एखाद्या कंडक्टरच्या एरियामधून जेवढे चार्जेस फ्लो होतात त्या चार्जेसचा काउंट म्हणजेच काय असतो? इलेक्ट्रिक करंट असतो, राइट? सेम मग इलेक्ट्रिक करंट हा कन्सेप्ट जर आपण कन्सिडर केला किंवा इलेक्ट्रिक करंट हा पॉइंट जर आपण कन्सिडर केला किंवा ही डेफिनेशन जर आपण कन्सिडर केली तर याचे एसआय युनिट काय असेल? तर सिंपल आहे, याचं एसआय युनिट आहे एम्पियर. आणि मग तुम्हाला क्वेश्चन विचारला जाईल डिफाइन 1 एम्पियर. मग आपण असं डिफाइन करू शकतोय की करंट 1 एम्पियर आहे असं आपण केव्हा म्हणू शकतोय की ज्यावेळी 1 कुलोम्ब एवढा चार्ज एका सेकंदासाठी कंडक्टर मधून आपण फ्लो केला त्यावेळी त्यामध्ये त्या कंडक्टर मध्ये तयार होणारा करंट हा किती असेल? 1 एम्पियर असेल. म्हणजेच काय की 1 कुलोम्ब एवढा चार्ज एका सेकंदासाठी एखाद्या कंडक्टर मधून फ्लो केला तर त्यावेळी त्याच्यामध्ये तयार होणारा जो करंट असेल तो करंट किती असणार आहे? 1 एम्पियर असेल. When 1 coulomb of charge is flow through the conductor for 1 second, then the generated current in the conductor is said to be 1 ampere. When we have to flow a 1 coulomb of charge through a conductor for 1 second, then the current generated in the conductor is said to be 1 ampere. This is the simple definition of 1 ampere and electric current. Now we have to move towards the next definition called as Ohm's law. Ohm's law. Ohm's is a scientist he explained the very easy relationship between potential difference and current. He explained the relationship between current and potential difference in 1828. Ohm explained the easy relationship between current and voltage or potential difference in 1828, and he stated its law named as Ohm's law. आणि तो आपला डिफाइन करायचा आहे, तो आपल्याला स्टेट करायचा आहे, स्टेट ओहम्स लॉ. The Ohm's law is that at constant physical conditions like temperature, pressure. Simple definition: at constant physical conditions, the potential difference developed across two ends of the conductor is directly proportional to the current flowing through the conductor. Is directly proportional to the current flowing through the conductor. Again, at constant physical conditions, the potential difference developed across two ends of the conductor is directly proportional to the current flowing through the conductor, or at constant physical conditions, the current flowing through the conductor is directly proportional to the potential difference developed across two ends of the conductor. We have to remove the proportionality sign, then we have to get V is equal to R into I, where R is called as constant of proportionality. R is called as constant of proportionality, or R indicates constant of proportionality, and it is called as a resistance. This constant is called as a resistance. Then what is meant by resistance? Resistance is the opposition offered by the flow of electric charges. The opposition offered to the flow of electric charges is called as a resistance. Means resistance opposes to the flow of charges through the conductor. When the number of charges are moved through the conductor, at that time the resistance opposes to that charges, and hence it is called as a resistance, and resistance is measured in ohm. Then next one, conductance. It is exactly opposite to that of the resistance. The reciprocal of resistance is called as a conductance. The reciprocal of resistance is called as conductance, or the reciprocal of conductance is called as a resistance. Both are opposite to each other. This is the simple introduction related to the current and electricity. Now we have to move towards the next point. Just start the syllabus of current electricity, and the name of that point is Kirchhoff's laws. Right? Now we have to move towards the next point, named as Kirchhoff's laws of electric network. The point is simple: Kirchhoff's laws of electric network. First, we have to see some terms related to the Kirchhoff's laws. First term is junction. We know that what is meant by junction. We know that what is meant by loop, and we know that what is meant by branch. We have to define three definitions, and then we have to move towards the first law, Kirchhoff's first law, called as current law or called as junction law. First, to define the definitions. Junction: any point in an electric circuit where two or more conductors are joined together is a junction. We know that, suppose we have to draw such a diagram. Suppose this is first conductor, this is second conductor, and this is a third conductor. And when these three conductors are joined to a single point, then this single point A is called as a junction, because we have to consider three conductors. Therefore, this is first conductor, this is second conductor, this is third conductor, and when the number of conductors are joined together, that joined single point is called as a junction. Therefore, point A is act as a junction, right? When conductor 1, 2 and 3 are joined to a single point A, hence the point A is called as a junction. Second definition, loop, any closed conducting path in an electric network is called as a loop. For example, we have to consider one loop. Suppose here we have to consider one battery like minus plus, then here one resistor, here one capacitor, and then finally we have to join this. This is key. This is key, right? This is battery E. This resistor R, capacitor C, and key K. This is called as a closed loop. This is called as closed loop, or this is called as loop only. It may be closed or unclosed. This is called as a loop, right? Means loop, any closed conducting path in an electric network is called as a loop. Next one, branch. A branch is any part of the network that lies between two junctions. This is called as a branch. Means when you have to consider two junctions. For example, we have to consider there is one junction, junction A, and we have to join this part with another junction B, and the portion between both is called as a branch. The portion between both is called as a branch, because branch is any part of the network that lies between two junctions. Means the path between two junctions is called as a branch. These are the three simple definitions. The definitions are again junction, any point in an electric circuit where two or more conductors are joined together is a junction. Second one, loop, any closed conducting path in an electric network is called as a loop. And third, branch, a branch is any part of the network that lies between two junctions is called as a branch. These are the three simple definitions. So the next point is Kirchhoff's first law, in bracket current or junction law. Means Kirchhoff's first law is also called as current law or junction law, because this law is totally related to the current, hence it is called as a current law, and all these currents are equate in a single point, hence it is called as a junction law. Means there are three names. First is the Kirchhoff's first law, second one is the junction law, third one is the current law, but law is single, right? First we have to see what is the statement. Statement is that the algebraic sum of all the currents at any junction is equal to 0. Means when you consider the number of currents, then the sum of that number of currents always is equal to 0. This is the simple statement. The algebraic sum of all the currents at any junction is equal to 0. We know that this is the given diagram for Kirchhoff's first law, and we know that this is the junction. Therefore, the large number of conductors we are considered, and we see here the direction of currents. Some currents of the conductor move towards the junction, and some currents are move away from the junction, right? Means current current moves towards the junction, current moves away from the junction, and when you have to add all the currents, then the equality of that current is always equal to 0. This is the simple statement of Kirchhoff's first law. Again, statement is that the algebraic sum of all the currents at any junction is equal to 0. Means in mathematical form, summation over I is equal to 1 to n, I is equal to 0. This I indicates 1, 2, 3, 4 up to n. Means here we have to consider the number of currents. We have to consider and the number of currents. Therefore, here we have taken I means we have to take 1 to n. And in mathematical form, summation over I is equal to 1 to n, I is equal to 0. Very important part in this point is sign convention. Sign convention is most important part in the Kirchhoff's first law and Kirchhoff's second law. The first sign convention is that the current arriving at the junction are taken as positive. Means the current flowing toward the junction is taken as positive. Here in this diagram you will see this is the current flowing away from the junction. This is the current flowing towards the junction. This again current flowing away from the junction. This is the current flowing towards the junction. This also current flowing towards the junction. This current flowing away from the junction, and again this current is flowing towards the junction. Means in this diagram we have to see the number of currents are flowing toward the junction and number of currents are flowing away from the junction. In this diagram, the current I1, current I3, I4 and I8 are the current I1, I3, I4 and I7 are flowing away from the junction. Therefore, these current are taken as negative. And current I2, current I5, current I6, current I8 are flowing towards the junction. Therefore, these current are taken as positive. Means sign convention are simple. The current flowing towards the junction is taken as positive, and the current flowing away from the junction is taken as negative. In simple form, the current arriving at the junction are taken as positive. Means the current arriving at the junction flowing towards the junction is taken as positive, and the current leaving at the junction are taken as negative. Means the current flowing away from the junction are taken as a negative. This is the simple sign conventions. We know that this point is very simple. Here we have to see what is meant by Kirchhoff's first law or statement of the Kirchhoff's first law. It is also called as current law, or it is also called as junction law. We know that what is the statement? Statement is that the algebraic sum of all the current at any junction is equal to the 0. That is summation over I is equal to 1 to n, I is equal to 0. Then we have to see the sign convention. The current arriving at the junction are taken as positive, and B, the current leaving at the junction are taken as negative. And then we have to apply the Kirchhoff's first law to the given diagram. Right? Here we have to given one diagram, and in this diagram we have to apply the Kirchhoff's first law. Right? Here we have to apply Kirchhoff's first law. Right? We start from the I1. We have to add all the currents, because the statement is that the algebraic sum of all the currents at any junction is equal to 0. Therefore, we have to add all the currents and equate them equal to 0. Right? First, starting from I1. We know that this is the I1. What is the direction? Direction is away from the junction. Therefore, we have taken minus I1 because direction is away from the junction. I2 towards the junction, taken as positive, plus I2. Third, away from the junction, minus I3. Fourth, away from the junction, minus I4. Fifth, towards the junction, plus I5. Sixth, again towards the junction, plus I6. Seventh, away from the junction, minus I7. And last number, towards the junction, therefore I8 is equal to 0. Means here you have to consider all the currents according to the sign convention. We know that the first current is move away from the junction, therefore we have to take negative. The second current flowing towards the junction, taken as positive. Third current and fourth current moving away from the junction, taken as negative. Fifth current move towards junction, taken as positive. Sixth current towards junction, taken as positive. Seventh, away from junction, taken as negative. And eighth number, move towards the junction, taken as positive. And this all the currents are equal to 0. Now we have to take the positive current on one side and negative current on the other side, and we have to equate both the currents, right? We have to take the positive current as it is, and we have to move the negative current on the opposite side of the equal side, right? First I2, then plus I5, then plus I6, then plus I8 is equal to, when negative currents moves from one side to other side, they becomes positive, right? Therefore I1 plus I3 plus I4 plus I7. This is the Kirchhoff's first law. This is the statement, or this is the equation for Kirchhoff's first law or junction law or current law, right? This is the simple equation in Marathi. तर आता आपण काय बघितलं आहे, किर्चॉफ्स फर्स्ट लॉ. याच लॉला काय म्हणलं जातं, करंट किंवा जंक्शन लॉ म्हणलं जातं. यालाच म्हणलं जातं करंट लॉ किंवा यालाच म्हणलं जातं काय, जंक्शन लॉ. त्याचं स्टेटमेंट काय आहे बघा, the algebraic sum of all the currents at any junction is equal to 0. तुम्ही कोणताही जंक्शन कन्सिडर करा, त्या जंक्शन जवळ असणारे जे सगळे करंट्स आहेत, त्या सगळ्या करंटची जेव्हा आपण बेरीज करतोय, तर ती बेरीज कशाशी इक्वल असते, 0 शी इक्वल असते. पण काय बघितलं बघा, the algebraic sum of all the currents at any junction is equal to 0. that is summation I is equal to 1 to n, I is equal to 0. म्हणजे कोणतेही जंक्शन जर तुम्ही कन्सिडर केलं, तर त्या जंक्शन जवळ जेवढे करंट आहेत, त्या सगळ्या करंटची आपण बेरीज केली, तर ती कशाशी इक्वल असते, 0 शी इक्वल असते. हे आपण इथे इंडिकेट केले. त्यानंतर आपण साइन कन्व्हेन्शन बघितलं. त्याच्या अगोदर आपण डायग्राम बघूया. या डायग्राम मध्ये आपले जंक्शन दिसतो, हा जंक्शन, आणि हे साइडचे जे आहेत ते 8 कंडक्टर्स आहेत, आणि या 8 कंडक्टरमधून काय होतोय, तर करंट फ्लो होतोय. आता करंट फ्लो होताना या सगळ्यामधून सारखा करंट फ्लो होत नाही, तर काही कंडक्टर मधला करंट हा जंक्शन कडे जातोय आणि काही कंडक्टर मधला करंट हा जंक्शन मधून बाहेर पडतोय. तर याच्यामध्ये आपण एरो इंडिकेट केलेले आहेत. आता याच्यामध्ये इंडिकेटला एरो नंबर I1 म्हणजे करंट नंबर I1, करंट नंबर I3, I4 आणि त्यानंतर I7 हे जे आहे हे जंक्शन पासून बाहेर पडत आहेत. आणि याच्यामध्ये काही करंट्स ज्याच्यामध्ये I2 आहे, त्याच्यामध्ये I5, I6 आणि I8 आहे, हे जंक्शन कडे फ्लो व्हायला लागले. म्हणजे जे करंट जंक्शन कडे फ्लो व्हायला लागले त्यांना आपण पॉझिटिव्ह म्हणून कन्सिडर करतोय, आणि जे करंट जंक्शन पासून बाहेर पडत आहेत त्यांना आपण काय म्हणून कन्सिडर करतोय, निगेटिव्ह म्हणून कन्सिडर करतोय आणि तेच आपण कशामध्ये इंडिकेट केलंय साइन कन्व्हेन्शन मध्ये. आपण काय म्हणतोय की जे करंट जंक्शन कडे मूव्ह होतात त्यांना आपण काय म्हणून घ्यायचं पॉझिटिव्ह म्हणून घ्यायचं आणि जे करंट जंक्शन पासून दूर जातात त्यांना आपण काय म्हणून घ्यायचं निगेटिव्ह करंट म्हणून घ्यायचं. तेच आपण इथं काय केलंय इंडिकेट केलंय. आणि मग या डायग्राम मध्ये आपण काय करणार आहे तर किर्चॉफचा फर्स्ट लॉ अप्लाय करायचा. लॉ अप्लाय करायचा म्हणजे काय करायचं की जे करंट टुवर्ड्स जंक्शन आहेत त्यांना पॉझिटिव्ह म्हणून घ्यायचं, जे करंट अवे फ्रॉम द जंक्शन आहे त्यांना काय म्हणून घ्यायचं निगेटिव्ह म्हणून घ्यायचं. तेच आपण इथं काय केलेलं आहे इंडिकेट केलेलं आहे. म्हणून आपण मग अप्लाय केलं I1 साठी अप्लाय केला तर I1 अवे फ्रॉम द जंक्शन आहे म्हणून निगेटिव्ह घेतलं. I2 साठी अप्लाय केला टुवर्ड्स जंक्शन आहे पॉझिटिव्ह, I3 साठी निगेटिव्ह, I4 साठी निगेटिव्ह, I5 आणि I6 साठी पॉझिटिव्ह, I7 साठी परत निगेटिव्ह आणि I8 साठी परत पॉझिटिव्ह आणि ते आपण इक्वेट केलं 0 ला. आणि त्याच्यानंतर आपण काय केलं की ज्या पॉझिटिव्ह टर्म्स आहेत त्या एका साइडला मूव्ह केल्या आणि ज्या निगेटिव्ह टर्म्स आहेत त्या अदर साइडला मूव्ह केल्या. आणि फायनली आपण असं कन्क्लूड करू शकतो the current flowing towards the junction is always equal to the current flowing away from the junction. म्हणजेच काय की जेवढा करंट हा टुवर्ड्स द जंक्शन फ्लो होतोय तेवढाच करंट काय होतोय अवे फ्रॉम द जंक्शन फ्लो होतोय. हे आपण याच्यामध्ये काय केलं आहे इंडिकेट केलं आहे. तर फर्स्ट लॉ आपण बघितला याच्यामध्ये करंट इलेक्ट्रिसिटीमध्ये आपण काय बघतोय किर्चॉफ्स लॉज बघतोय आणि त्याच्यामध्ये आपण किर्चॉफ्स फर्स्ट लॉ बघितला आहे त्याला आपण करंट किंवा जंक्शन लॉ म्हणतोय. तर मी तुम्हाला एक डायग्राम याच्यामध्ये देतो आहे. तर हा होमवर्क असेल उद्याच्या लेक्चरचा म्हणजे आताच्या लेक्चरचा हा होमवर्क असेल तर तुम्ही काय करायचं आहे ते सॉल्व करून मला त्याचे आन्सर्स पाठवायचे आहेत म्हणजे हा लॉ अप्लाय करून. तर काय असेल बघा डायग्राम. तर या डायग्राममध्ये तुम्ही काय करायचा किर्चॉफ फर्स्ट लॉ अप्लाय करायचा आणि याचे आन्सर्स मला पाठवायचे आहेत. राईट. कॉम्प्लिकेट आवश्यकता आहे तुम्ही ते आन्सर मला पाठवायचे आहेत. सिंपल आहे. डायग्राम सिंपल आहे. होया काय आन्सर करते याला आपण I1 म्हणू, I2, I3, I4, I5, I6, I7, I8, I9, I10, I11 आणि I12 याच्यावरून तुम्ही किर्चॉफ लॉ अप्लाय करायचा आणि याचे आन्सर्स मला पाठवायचे. हा तुमचा आजचा काय असेल